Hello again. This is Mark Summers from Summers Technical Services. We're moving on with our waveguide training sessions. Here we're moving from the basic part models and basic assembly model into creating configurations using design tables and global variables to not make one version of the part and one version of the assembly, but to make all of them. And this extremely powerful tool in most high-end 3D parametric CAD tools, including Solidworks. And so let's get started. All right, here's our completed waveguide part model. And I'm not going to bore you with two videos, one for the waveguide and one for the flange. Once you figure out how to do the waveguide, you just use the same principles to do the configurations on the flange. And if you have any questions, as usual, I'll answer them during class. All right, so step one is to create global variables. So we're going to go Tools, Equations, Global Variables. There it is right there. It says add a global variable. And so what we're going to do is we're going to add a global variable. This is my waveguide. Your numbers will be different. We're going to add global variables for these numbers that change in the part so that we can use that global variable to define these configurations. So I want to define these global variables, and we can call these whatever we want. You just got to remember what you call them. Uppercase and lowercase makes a difference, so keep track of what you're doing. A in my case is going to be 34. B is 170. C 420. And D is 250. All right, so those global variables are defined in my model, and they're not doing anything yet because we haven't pointed to them in any kind of a parameter in my model. And so now the second step is to edit this sketch that contains those parameters, and we're going to change these. And so I'm going to start with A here, double click, and I'm going to say equals. And it's going to give me this pop-up global variable, and I want to arrow over and choose A as my global variable. And so now, instead of being equal to 0.340, it's equal to A. A at this moment in time happens to be 0.34, so the model didn't change, but is now pointing to the global variable A instead of the number 0.34. And you get this little nice indicator here, which is kind of handy. That'll let you know that it's driven by a global variable. So double click. You have to fast double click on these numbers, otherwise you won't get the pop-up. So if I fast double click on that one, I want to say equals whenever this thing comes back to life. And hit the equal sign, arrow down to global variables, arrow over to the right, arrow down, and grab that global variable. And again, it'll give me that same symbol. 420 is C, equals global variable C. Prove that. And then this last one. If you click too slow, let's show you what happens when you click too slow. If you're an old man like me and you click slow, you're going to get that. And typing in equals D is not going to work. You need to double click fast. Maybe I'm not so old after all. Double click fast to get this dialog like this. And you can use that equal sign. All right, so now all of those dimensions are driven by that global variable. So I get out of my sketch, and my part has changed none. The part model hasn't changed at all. It's just that now those particular dimensions are driven by global variables instead of numbers. All right, so let's do the fun stuff. We're going to go move over. We've been working in a feature manager since day one. We've got a lot of different managers up here. Some of them have to do with the simulation modules we've used. Some of them have to do with the display manager. There's Dim Expert. We'll go over all these eventually during the semester. Property manager. What we want to do is go to configuration manager. Go to configuration manager, and I get another tree over here, and we get a different tree depending on what mode we're in, what manager we're in. So configuration manager is right here. We've got a default configuration. Every brand new part model you start is going to have a default configuration. It's just whatever you build. But we're going to create a new set of configurations, and instead of building just one configuration, we're going to build all of them. All right, so let's go do that. So the way we do that is we're going to right click. Oh, come on. We're going to right click on this. No, we're going to come up here to the tools. Where is it? Tools. No, insert tables. I knew I could do this. Insert tables, design table. All right. So we're going to do that, and we get this dialog box, and these are all really, really important parameters. And if you want to learn about them, you need to take my SolidWorks Advanced class. But for here, we're just going to say we're going to make a blank design table. Won't worry about the other options, even though they're very important. We'll go blank and say OK. And now what happens? I get to wait. I'm sure it's working real hard. Well, that's doing that. Let's go find my set of parameters here. It's taking forever. There we go. Finally, something's happening. All right. No, it's still not working. I need to talk to the IT department and get me a new computer. This could be a problem. Stephen Tyler would say, "Oh, just should press pause here." Here we go. Jeez Louise. All right, we're going to cancel out of this, and we're going to get to something that looks interesting right here. So this is our design table. It looks like Excel because it is Excel. All right, you got to pay attention to where you're at on the screen. First instance, we're going to type in our first instance. So an instance is one of the configuration name. We're going to call this NRG, in my case 036-00-01-WR19. All right, that's going to be the name of our first configuration. And if you make a typographical error in the spreadsheet, you're going to start over because it's unforgiving. 1, 2, 3, 4, 5. I'm going to Control D to roll that down so I don't make a typographical error. And I'm just going to change this last digits here to match the tables that I gave you in class. All right. Now you need to remember to go to B2. B2 is the cell that we're going to start defining the columns, and this is SolidWorks programming language. If you get this wrong, it just won't work. So here it is, $value. You have to do all caps, at, and then we're going to type in the global variable, which in our case is A, and then we're going to do at, and then lowercase equations. So that's it. When you hit enter, it's going to think that this is a hyperlink to some email address because it's got an @ symbol in there. If you click on this, it's going to launch an install program to try to install Microsoft Outlook on your computer, and it's going to be a big mess. So don't click on this thing. Instead, do a Control K and turn off the link so that it's not there. All right, we're going to shift and we're going to arrow to the right. We're going to do this 4 times. I'm going to do a Control D to roll it. Whoops. I'm going to do a Control D to roll it to the right. What am I doing wrong here? 1, 2, 3, 4. Not Control D. Excuse me. Control R. Roll it to the right. All right, there's A. I'm going to come over here and change this to capital B. And I do this because I don't want to make typographical errors it helps me not do that. And you can see when I type these in, it's going to automatically add that hyperlink, which is unfortunate. But if I Control K and remove the link, it'll go away and won't allow me to screw it up by clicking on the link. All right, last thing I like to do is right-click, Format Cells, and rotate these things around so I can read them. That looks much better to me. All right, now we're going to enter these values. Where'd they go? We're going to enter these values for, that's just one of them. Where's all of them? I want the big sheet here. This thing over here. Let's do this again. I just had it a minute ago. Here we go. We're going to type in all the ABCD values for all the different configurations. So let's type those in. I'm going to start here. This is WR. Oop, I already screwed up something. Why didn't y'all say something? That's WR22. All right, so ABCD, ABCD. So for WR19, A is 188. B is 094. And this is going to get boring because you got to hear me talk, but first one I want to do, here's WR22. Typing these numbers in. Should have some music playing or something. 28. Sure, I'm going to make a mistake here, but I'm sure y'all will catch it. Now we're getting close. 30, 40, 170, 42. One more row. 42, 170. All right. So that wasn't too painful. So make sure you start. This guy here has to be at cell B2. It's going to say first instance when you open this thing up. That's where you put your first instance. You got to put these things in, like you know, you got to remember what you do here because these are going to be referenced in the assembly model configurations. So if you muck this up, your assembly model is going to be mucked up. So at this point, you just cross your fingers and close Excel and hope that it works. And of course it worked because I did it all right. And so now instead of having one model, I've got all the models. There's one. I'm double clicking on this configuration. That's the coolest thing freaking ever. All right. So now I've got all the configurations. And I'm going to leave it on default. And that'll be the one you designed. And now I can go back to the model tree. Now there's one more thing we need to do. Is there's another parameter that's driven by A, B, C, and D. And it is these fillets that go through the center of the part. They are related to A, B, and C, and D because our inside bend radius needs to be maintained at 0.5 inches. And we're not defining the inside bend. We're not defining this bend right here. What we're defining, or what you're defining, is the center line of that path. And so if you put in 0.5 radius for the center of that path radius, your part's going to be screwed up because you're defining the center of the path instead of this guy here. And so you need to go think about how you're going to put in numbers for this radius and this radius. This radius, this radius, and this radius looking down from the top are all equal. And this radius looking in from the front is a different number. But they're all related to those parameters. You need to tie those parameters. So you need to edit your 3D sketch, edit those fillet values, and your part will update correctly. All right, so that's the waveguide part. You can do the same thing on the flange part, use the same exact strategy. I won't waste your time with another boring video showing you how to do that. So just use this concept here to also do your waveguide, your flange. You're going to have parameters C and D. You don't need A and B. That'll be one of the quiz questions. Why don't I need to know A and B on the flange? Well, figure it out. We don't need A and B. We need C and D. We also need those two outer diameters. Oh, I call them OD1 and OD2. And you can call them whatever you want, but you got to take advantage. You got to take not advantage of them. You got to take account of them because they change depending on what size waveguide you had, even though it's not in that table. So look at the specification I gave you, and make sure those are included so that it updates correctly. Otherwise, your configurations are going to be cattywampus. All right, so that's going from a good model to a great model on the waveguide part. That applies to the flange part. Use the same strategy. And in the next video, we're going to talk about how to make the assembly configurations, which is going to be another beautiful thing. So stay tuned for that one. And until then, thanks for watching. Make sure to hit the subscribe button so you get notifications on upcoming videos. And we'll see you next time.